Hi, we're continuing with my review of cell biology and life science in a nutshell. We're learning about fat molecules. So these are saturated or unsaturated. So again, glycerol, which is three carbons, five hydrogens, three hydroxy groups, plus a fatty acid chain, which is carbons linked up to each other in three fatty acid chains, and a glycerol backbone uh, in a dehydration reaction where three water molecules are lost forms a fat molecule. Triacylglycerol is another word for fat molecule. That's what it looks like. So fat molecules may be saturated or unsaturated. So depending on the fatty acids. So if the fatty acid has only single bonds, these are called saturated tails, fatty acid chains. If they have double bonds, these are called unsaturated. So, saturated again, if they have only single bonds, um, they are found usually like in meats. So, like stearic acid and palmitic acid are saturated fatty acid, um, and unsaturated, like oleic acid, for example, are usually liquids, are called oils at room temperature because they have a double bond. They're unsaturated. One double bond is called mono unsaturated. More than one, for example, olive oil is mono. Poly is like canola oil having more than one double bond. Okay, so here it says that unsaturated fats help to lower blood cholesterol levels, whereas saturated fats contribute to plaques in the arteries. Um, so, unsaturated fats or oils are usually of plant origin and contain cis unsaturated fatty acids. So, with hydrogens on the same side, cis and trans indicate the configuration of the molecule around the double bond. Excuse me. If hydrogens are present in the same plane, it is referred to as a cis fat. If hydrogen atoms are in two different planes, it is referred to as a trans fat. The cis double bond causes a bend or a kink, preventing the fatty acid from packing tightly. Therefore, they are liquid at room temperature. So these are more common in fats and do not clog arteries as quickly, being more flexible. So shown here, saturated. So stearic acid is an example. Unsaturated here, cis oleic acid. So it has a double bond here. Cis hydrogens on the same plane. Transoleic acid, the hydrogens are in opposite planes. So saturated fatty acids have hydrocarbon chains connected by single bonds only. Unsaturated fatty acids have one or more double bonds. Each double bond may be in a cis or a trans configuration, where the hydrogens are either on the same or cis plane, same side of the hydrocarbon chain, or on opposite sides. So if it is a cis, there is a kink produced in the chain. It's not a straight chain, as in a trans conformation of unsaturated, uh, or even saturated, which are straight chains. So, trans fats in the food industry, oils are artificially hydrogenated to make them semi solid and of a consistency desirable for many processed food products. During the hydrogenation process, gases bubble through oils to solidify them. The double bonds of the cis conformation in the hydrocarbon chain may be converted to double bonds in the trans conformation. So this is the opposite of liquefying uh, the fat. It's making it more solid for certain purposes. Margarine, for example, some types of peanut butter and shortening are examples of artificially hydrogenated trans fats. Recent studies have shown that an increase in trans fats in the human diet may lead to an increase in levels of low density lipoproteins or cholesterol of LDL, um, which in turn may lead to plaque deposition in arteries, resulting in heart disease. Many fast food restaurants have recently banned the use of trans fats, and food labels are required to display trans fat content. So, essential fatty acids are fatty acids required for biological processes but not synthesized by the human body. Consequently, they have to be supplemented through ingestion or eating via the diet are nutritionally very important. Omega-3 fatty acid or alpha linoleic acid (ALA) falls into this category and is one of the only two fatty acids known to be essential for humans. The others being the other being omega-6 or linoleic acid fatty acid. These polyunsaturated fatty acids are called omega-3 because the third carbon from the end of the hydrocarbon chain is connected to its neighboring carbon by a double bond. Um, Salmon, trout, tuna are good sources of omega-3 fatty acid. Research indicates that omega-3 fatty acids reduce risk of sudden death from heart attacks, reducing triglycerides in the blood, lowering blood pressure, preventing thrombosis by inhibiting blood clotting. They also reduce inflammation, helping to reduce risk of some cancers in animals as well. Here shown is the diagram of omega fatty acid. Alpha-linolenic acid is an example of an omega-3 fatty acid. It has three cis double bonds and as a result a curved shape. For clarity, the carbons are not shown. Each single bonded carbon has two hydrogens associated with it, not shown. So the key terms: hydrogenation is the chemical reaction of hydrogen with another substance, especially with an unsaturated organic compound, and usually under the influence of temperature, pressure, and catalysts. An ester is a compound often formed by condensation of alcohol and an acid by removing water. It contains the functional group carbon-oxygen double bonds joined via carbon to another oxygen atom. Carboxyl is a univalent functional group consisting of a carbonyl and a hydroxyl functional group, so a CO and an OH, characteristic of carboxylic acids. So COOH is a carboxyl. Um, So ester carbon, one oxygen single, one oxygen double now.